Okay, folks, the goal here is threefold. One, to create a application that allow us to train and serialize AI models, build an interface that allow us to create data and then do some inference tests on the models. And lastly, some tools for shaping our data, augmenting it to create synthetic data, splitting it up and such. The I would highly recommend watching this video. So Ray is Online is the name of her channel, and I used this. I typed line for line as she does to create my neural network, the backbone of this network. I highly recommend it. Now, you want to have some understanding of neural networks and definitely Java going in, or it'd be a little bit difficult to follow. But she does an amazing job and types every single line in the tutorial, and you can do the same. Let's take a look here. I just got done training a model. Now, if you train, use this model and you train on the minced, I think that's how you pronounce it, data set. 60,000, I think, is the number of training samples. It trains at about 90%. But my goal here was to save my model and then be able to create my own data set, my own interface to create data and obviously to run inference tests on that data to test it. So that's what we did here. So I just trained a model. Now, this model this is it right here. So I'll explain how I serialize them. It's not how you would do it professionally, right, if you're using tools like TensorFlow or such. But this original data set, it only has 4,000 samples. And of these 4,000 samples, I only created about 1,000 of them. The rest I generated synthetically by taking those samples and rotating them, scaling them, transposing them, right, shifting them a little bit and blurring them to have extra data so I didn't have to keep creating data. So a couple things. One, it's not a lot of data anyway, and two, it's most of it is synthetic. But I still trained at what was it? I think it was 70%, and it's 70%-ish. My naming convention here is the model, the learning rate for the I think I have the convolution layer first, then the learning rate for the fully connected layer, the number of epochs that I ran, and then although this is wrong, I'll show you why that's wrong in a second because this stopped early and I should fix that. And then the actual rate, so it was 70% was the rate. The reason why it was 100 because that's what my loop is set to, but I should change my code, and we only ran 40, so I'll fix that. So this right here, this 100 should say 40 instead. And again, we've got 0.1% for the learning rate of the fully connected, 0.1% for the convolution layer. Okay. So let's see how I created this data. So the way I did it was this. Let's get rid of all of this, so we can delete these, and I'll just keep that final, so we can use it in a second here. But let's delete this. Okay, so if we go to the shape tools here, what this will allow us to do is, and you can drill in and see how I did it. But it'll allow you to point it at a file, give it a name, augmented data. This is going to give us 4 times the amount of data we pass in, and then we're going to split that data, and we'll split it 80-20. So let's go ahead and run this, and we'll get those 2 files. Well, we'll really get 3 files. We'll get the augmented data, and then we'll get the 2 split files. So there we go. So we've got the augmented data. Again, this is 4 times the size of the original data. And then this one is going to be 20% of this, and this one is 80% of this. And that's what we ran our training against. You could further split it again. So you could pass augmented data in here, and then you'd get 4 times that, right? Which was 4 times the original. Eventually, you want more pure data that you create. We'll talk about that in a second. Okay, so let's look at the training here, and the 3. There's shape. Let's go to the training of the network. And basically, I have it set up so you can do 3 things. So you can train and serialize, you can fine tune, and then you could just run some tests. So to train and serialize, we're pointing at those files that we just created here. And we set our learning rates. One of the most difficult things is figuring out what the proper learning rate should be. There's a lot of tools and videos out there how to do it. We set up our neural network. And again, watch Ray's videos to learn how to do this. It's amazing. I set it up for early stopping. And the reason is we want to we don't want to keep running if we reach a plateau, which I did at 70%. So it stopped early instead of going to 100, right? It stopped at 30. And then we go and train, right? So I have it set up for 100, and it does a training run. It does a test run, does some outputting, obviously, and then checks if it should stop early, and then just kind of keeps going, and then eventually it prints out and it shouldn't have been epochs. Again, this is why it was 100. That's why this 100 is right here. So we want to change this, and we want to capture what the rate is when we stop. And I'll do that before I post it up again, or maybe I won't. We'll see. So that's it. Fine tuning. All you do with fine tuning is instead you're going to load up a model, right? So you can set. You notice I'm just pointing at the model checkpoint. What happens is during the training run, every single epoch, it creates the checkpoint. It's here. It just hasn't updated. I don't know why there isn't a refresh button here somewhere, but anyway, it's here. At some point, it'll refresh. Let's see. So that's pretty good. If you want to use this, you should be able to get up and running. And the last thing is, let's do this. I could just run it against the model checkpoint, but just for fun, let's refactor, rename. Let me copy this off to type it, and we can cancel this. Let's close up this one. Close up this one. Now let's just look at the last chunk, which is the inference tests. If we come here and we go to handle a guess, I'm going to try to change all of this to predict. It sounds more confident. Let's drill into predict digit, and here is, again, you could leave this as model checkpoint, since model check, but there is a checkpoint right on the epoch that actually generated the actual final model. But let's go ahead and pop that in there. So it's going to load up that model, and it's going to make a guess against that. Probably could load this up, and so I don't have to keep loading it every single time I do a prediction, but that's okay. Let's go to Inference, and let's do a test or two. Oh, and I want to show you how to create some data too. That's right. Okay. So if you come here, the only reason you have to put a value down here is so it can keep a running tally for you if you want to do that. But we could say 1. And let's draw a 1. 1's a tough because sometimes it's going to think it's a 7, and let's see what happened. But I'm 1 for 1, and maybe I should just maybe I should stop there. Let's do the odds. So let's try a 3. And oh, nice. All right, we're doing pretty good. 5. I don't know why. Sometimes it doesn't like 5s. It just might be how I draw them. I'm not sure. Again, you got to change this, but you know. And again, the only reason to change it is so it creates a running tally. It's not going to. It'll give you a prediction no matter what you put here. What do we need? 7. We're doing pretty good. Hold on. Oh, how could it predict a 6 for that? It's a 7 for cripe's sakes. That's better. And then lastly, let's do a 9. See if we can keep at about 80%. 9s can be tough because here's the thing. Ooh, let me clear that. Let's try that again. 9s can be tough because as as you rotate the data, a 9 can start to look like a 9 can start to look like a 6, or again, obviously an 8 because and again, there's so little data here. So I'm actually pretty impressed that it's doing this good. But obviously there's our 8. Let's try that. Nice, nice. So 71%, and our model was 70%. So we're it seems to make sense. Okay, now while I have this open, let's just look at the last tool. And the last tool is how do you generate data, right? And how did I actually create this data up here? Well, all you do is this. I have this set up, right? You're going to start at 0 and start drawing zeros, right? So I'm going to draw a 0. It's not a great one. And you can hit the save button, but I got sick of coming up here. It took forever, so you could just right click for save. And we've now done one. There's 2 of them. And, kind of draw them different locations. And instead of adding to data while I'm doing the video, I just created a scratch. I'll show you that in a second. But so it's just putting the data in there just so you could see it. And it's going to keep count. Obviously, you can see it doing it up there. And I kept forgetting when I got to 10, even though I'm saying it up here. So I finally created a little dialog box, and it'll pop up and tell me I saved 10 already, and it increments, so I know what this is. By the way, this is the label. So as we create this, it's going to serialize what it finds on the canvas here. But I need a label for my data, and that's what that's the label there, right? So I'm sure you don't want to keep seeing me do this, so that's it. We'll just do 3 of them, and I would also do ones like this and this. I did some like this, kind of crooked. Okay, so there you go. You get the idea here. Let's close this up, and let's see what's inside of Scratch. So if you look in here, what you'll notice is the very first value is the label, and then after that is 28 times 28, 784. Values. Now, one thing you might want to do, and you can see I stopped early with the ones. One thing, I'll show you this last thing and I'll be done. 12 minutes, not too bad. The last thing I'll show here is I wanted to be able to kind of look inside of my augmented data and just see how I was doing, right? And it was the code creating data that's actually legible still as an 8 or whatever it is. So what I did was, I had actually done this before this as I was trying to learn all of this, but let's open in, what do I want? Oh, open in folder, Explorer. And I figured it might be helpful for you folks, so I gave you this file. And then what you can do is, you can go inside and you can open up the augmented data. It doesn't matter if you open up test or train. Again, it's shuffled before it created this 8020. It shuffled the data. So you can open any of the 3 of these, but this one will be the smallest. So let's open that one up. And you can see I tested a 6 last, but just grab anything. Remember, the first is your label, right? So let's test a 3. I'll do Control Shift right arrow. I can copy that. And let's come here. This is the label. I'm going to right click and paste transpose, and voila, there you go. It's a 3, and you can see, right, the software kind of shifted a little bit. Now this is different than the minced set in that the minced set kind of has multiple cells that are the same, so it's thicker. So what you could do is, if you wanted to try this against the minced data set, I mean, it'd be easy to do. Just run. I mean, I've got mine trained here, but you could do the same thing, right? So just add those here, and then when you train, go down to your to train it. You're just going to point at the train. I think it's train minced and test minced are the names of them. But the thing you might want to do is, well, if you're then going to run inference tests to get it against it, you might want to make your lines a little bit thicker. So what you could do is you could go in, let's see here, go into the controller and draw. So oops, oh, here it is. It did find it. So what you could do is you could go in and make it a little bit thicker, right? So, and see if that would make any difference, right? Set it to 12 or something, and now you'll see when you run this and you draw. Right, much thicker. All right, so cool. Oops, I'm in a different window. Sorry about that. But anyway, so cool. Okay, so hopefully that helped you kind of get up and running a little bit if you want to play with it. I realize, all the file names and stuff are hard coded in, but again, it was meant to be a sandbox, and hopefully it helps a little bit.